Hi everyone, I'm Navita and I'm a developer advocate at Meta. This Build with Meta Llama video series demonstrates the capabilities and practical applications of Llama models for developers like you so that you can leverage the benefits of what Llama has to offer and incorporate it into your own applications. In this video series, we'll discuss some of the various ways in which you can run Meta Llama models and go over some of the resources available to you to get started. In this first video, we learn how to run Meta Llama on Linux OS by getting the weights and running it locally, with a step-by-step tutorial to help you follow along. In our later videos, we'll explore some of the other ways to run Llama. We'll also go over the various resources and demos available to you to help you get started with using and integrating Llama into your own use cases. So let's dive in. At Meta, we strongly believe in an open approach to AI development. By sharing AI models openly, we extend their benefits to all corners of society. Last year, we open sourced Llama 2, and we recently released the Meta Llama 3 set of models, available both in 8 billion and 70 billion pre-trained and instruction-tuned versions to support a wide range of applications, unlocking the power of these large language models and making them accessible to everyone so you can experiment, innovate, and scale your ideas responsibly. Some of the capabilities of Meta Llama models include text generation. Our models can generate human-like text based on a given prompt or input. Language translation. They can translate text from one language to another. Summarization. They can summarize long pieces of text into shorter, more digestible versions. Text classification. They can classify text into different categories or topics. Sentiment analysis. Llama models can analyze text to determine the sentiment or emotion behind it. Question answering. They can answer questions based on the information contained in a given text. And dialogue systems. They can be used to build chatbots and other dialogue systems that can engage in natural sounding conversations. These are just some examples of what Llama models can do. With its powerful capabilities and efficiency, Meta Llama models can be applied to a wide range of natural language processing tasks. Now that we have a good idea of what Llama models are capable of, let's take a look at how we can run them locally. With a Linux setup, having a GPU of minimum 16 GB VRAM, you should be able to load the 8 billion Llama models in FP16 locally by downloading the weights from our website. Let's dive deeper into the steps required to run Llama models locally on Linux. If you have an NVIDIA GPU, you can confirm your setup by opening the terminal and typing NVIDIA SMI, which is a short for NVIDIA System Management Interface. This will show you the GPU that you have, the VRAM available, and other useful information about your setup. In my current setup, I'm on Ubuntu, specifically Pop! OS, and as we can see, I have an NVIDIA RTX 4090 with a total VRAM of about 24 GB, which means I should be able to run the 8 billion model comfortably on my setup. First, let's visit the Llama website and download the weights. To do that, visit our website and click on Download Models. Fill in your details in the form, select the models you'd like to download. In our case, we will be downloading Llama 3 models, so we'll go ahead and select those and click on Continue. Read and agree to the license agreement and click on Accept and Continue. Once you've requested the weights, you'll be able to see a unique URL on the website. You will also receive the URL in your email, and it is valid for 24 hours to allow you to download each model for up to 5 times. You can always request a new URL. It's now time to see how to get the weights and run the model locally on our machine. Let's open our terminal and make a new folder in our workspace. Let's call it Llama 3 Demo. It is recommended to use a Python virtual environment for running this demo. In this demo, we are using Miniconda, but you can use any virtual environment of your choice. Enter the new folder and clone the Llama repo by typing git clone followed by the repo URL as shown. For this demo, we want to make sure that we have the prerequisites installed. To run the model, we'll need to have wget and MD5 sum installed. For most Linux distributions, wget and MD5sum come pre-installed. To confirm if your distribution has wget, type wget version and it returns the version, as shown. If your distribution does not have it by default, you can install it by using apt-get install wget. Similarly, for MD5sum, you can confirm if your distribution has it by typing MD5sum version as shown and it returns the version. Next, let's enter the newly cloned repo folder and let's make sure we have all the package dependencies by typing pip install -e dot. We are now all set to download the model weights for our local setup. Our team has created a helper script to make it easy to download the model weights. To download the weights, in your terminal, type /download.sh as shown. It'll ask you to enter the URL from your email. Paste the URL you received in your email from Meta and press enter. It'll then ask you to enter the list of models to download. For our example, we'll download the 8 billion pre-trained model and the fine-tuned 8 billion chat models. So we'll type 8b, 8b-instruct and press enter. Now that the models have finished downloading, we can check if we have new folders with all the expected files. To do that, type ls and we see we have 2 new folders. Let's open one of them and we see it contains checklist, consolidated path, parameters and the tokenizer. Let's go back to our Llama 3 folder by typing cd ... Now we are all set to run the example inference script to test if our model has been set up correctly and works. Our team has created an example Python script called example text completion that you can use to test out the model. Let's open the script and briefly see how it works. The script defines a main function that uses the Llama class from the Llama library to generate text completions for given prompts using the pre-trained models. It takes a few arguments. Let's go over them real quick. Checkpoint directory. This is the directory containing the checkpoint files for the model. The tokenizer path is the path to the tokenizer of the model. Temperature. This parameter controls the randomness of the generation process. Higher values may lead to more creative but less coherent outputs, while lower values lead to more conservative but more coherent outputs. Top P. This defines the maximum probability threshold for generating tokens. Max sequence length defines the maximum length of the input sequence or prompt allowed for the model to process. Max genlen defines the maximum length of the generated text the model is allowed to produce. Max batch size defines the maximum number of prompts to process in one batch. The main function builds an instance of the Llama class using the provided arguments, then defines a list of prompts for which the model will use generator.textCompletion method to generate the completions. Now that we have a good idea of what the script does, let's go ahead and try running it. To run the script, let's go back to our terminal and while in the Llama 3 repo, type torchrun followed by the arguments as shown. Replace Meta Llama 3 8b with the path to your checkpoint directory and the tokenizer model with the path to your tokenizer model. By default, if you run it from this main directory, the path may not need to be changed. The nproc per node should be set to MP value for the model you're using. For 8 billion models, this value is set to 1. Adjust the max sequence length and the max batch size parameters as needed. We have set them to 128 and 4 respectively. Now press enter. And here we are. We see our Llama 3 8 billion model running. The model has gone through our prompts and provided us with the completions. I believe the meaning of life is to be happy, and it goes on to explain more about it. Similarly, it completes the theory of relativity for us. It even completes the email for us and translates words from English to French based on the examples that we provided. If you'd like to try out the fine-tuned chat model, We have a similar example called example chat completion that we have created to help you run and try out our fine-tuned chat model. To run the chat example, type .run followed by the arguments as shown. Note that in this case, we will use the Meta Llama instruct model and provide the correct tokenizer under the instruct model folder. Once those are set, type enter to run the script. And here we see our Llama 3 8 billion instruct model running. The model has gone through our questions and provided us with the answers. It gives us the recipe of mayonnaise that we asked for in detail, with variations as well. It also suggested what to see in Paris when visiting, with reasons why we should see those places. It even gives answers with haiku and only emojis as we asked in the prompts. A detailed step-by-step process to run on this setup, as well as all the helper and example scripts, can be found on our Llama 3 GitHub repo, which goes over the process of downloading, quick start, as well as examples for inference. A link to our GitHub repo can be found in the description box of the video. In this example, we saw how to run Llama models on a Linux setup by downloading the weights and running the model locally. This option is great when you want to keep all your data local and independent of any other APIs or services. If you prefer to consume information in a written format, we've also published a blog that will go over all the things we discussed in this video and more. The supporting blog can be found on our website and will also be linked in the description box below. In our next video, we'll take a look at how to run the Llama models on Windows, with another step-by-step demonstration of how you can set it up yourself. We hope you found this video helpful to provide you with insights and resources that you may need to get started with using Llama models. Thank you and see you in the next video.